Hello friends, welcome to Chemoholic. Today we are going to discuss about a topic of IIT JEE, that is what chemical kinetics. As we know, the chemical kinetics is a big chapter. I have divided this chapter into the multiple videos. Like there will be 4 or 5 videos will be coming. Like I have divided on the basis of their topic, rate of reaction, then instantaneous rate of reaction, then order of reaction. Even we have discussed about. I have put in this molecularity of reaction, collision theory, Arrhenius theory. This all. So I have divided in a form of videos, different videos. So in this section, in this video, we are going to discuss about chemical kinetics. What is basically a chemical kinetics, and even we'll discuss about the rate of reaction. So just take out your notebook and pen. Let's understand about the chemical kinetics, and even we'll discuss more about rate of reaction. At the end of the video, there will be some specimen question, even the solved example. So the even in upcoming video on the base of the every topic, so we are going to discuss about the rate of reaction. Let's start. And so basically, in case of chemical kinetics, the word chemical kinetics, if you'll see about the chemical kinetics deals with the kinetics of the reaction. Kinetics means speed of reaction. Means basically it's a reaction which deals with speed of reaction. It's a topic which deals with the speed of reaction. This term first time it was used by the two scientists, the Peter Weige and Cato Goldberg. Peter Weige and Cato Goldberg in year 1864. It was given by them, and they developed the concept of chemical kinetics by formulating on the basis of law of mass action. The question arises over here: what is the law of mass action? Let me tell you about the law of mass action. According to law of mass action, rate of any reaction is directly proportional to product of active masses of reactant, or we can say product of concentration of reactant raised to their stoichiometric coefficient. It means whatever the amount of concentration of reactant, it means rate of any reaction is depend upon the concentration of reactant raised to their stoichiometric coefficient. That is called as a law of mass action. On the basis of this law of mass action, they both explain about the chemical kinetics. Please do not get confused between the law of mass conservation. Law of mass conservation is mass is neither created nor destroyed. It will just convert it into one form to another form. So that is law of mass conservation. Here they used law of mass action, and in this chapter the role of law of mass action is very huge. We are going to find out the rate equation, rate law, rate constant, everything we are going to use with the help of law of mass action only. So and which state about they state about the chemical reaction is proportional to the quantity of reacting substances. They explain about the chemical reaction is any chemical reaction, the speed of any chemical reaction is proportional to the quantity of reacting substance. We can say the amount of substance undergoes reaction is directly proportional to the speed of reaction. Means more substances are getting more substances are reacting, so we can say the speed is more. That they conclude on the basis of the law of mass action. Okay, so they define a word called chemical kinetics. To understand the chemical kinetics, we should understand a topic called rate of reaction. Let's explore the topic about the of the rate of reaction. The main principal reason for the studying chemical kinetics. Okay, so there are two main reason for studying the chemical kinetics. The first one is what? To predict the rate of a particular reaction under the specific condition. The condition can be adjusted to make the reaction to go as a desired rate, either rapidly, slowly, or moderately. The field of chemical kinetics is useful in industry as condition for maximum yield of industrial products can be ascertained. So basically you must be aware about the many reactions are fast in nature, many reactions are slow. So we are aware about it, like in the universe we come across with many reaction, and these reactions, some of them are slow, some of them are fast, some of them are moderate. How we can conclude? For example, if the explosion of fireworks are very fast reaction, if you will add the formation of precipitate are very fast reaction, you can say. Same way you are getting the reactions like they take time, means like making of curd, ripening of fruits, they are taking too much time to happen. So we can say that these reactions are very slow reactions. If we'll say that hydrogen peroxide is there, hydrogen peroxide undergoes decomposition, so we can say it's a little moderate reaction, it takes time to happen, it is not happening suddenly, so we can say it is what, it's a moderate reaction. So in universe we are coming across with a moderate reaction, fast reactions, slow reactions. So to predict the speed of a particular reaction, the chemical kinetics is playing a very important role. Okay, to predict the mechanism of reaction, second point is what, to predict the mechanism of the reaction, the intelligent guess regarding the various elementary process responsible for formation of product can be made which should be consistent with the experimental data. So it is also helpful if we are performing some experiment, so how it is consistent data, how much it is changing, and with what time it is changing, with time how much it is changing, everything detail we studied under the chemical kinetics. If we study the chemical kinetics, we can explore this all important point. Okay, so let's move to a topic called rate of reaction. Basically rate of reaction is nothing but a call as a speed of reaction. Any reaction are having their own speed. They may be slow speed, they may be slow, they may be fast, they may be moderate. Now big question arise over here, that is the speed of any reaction we judge on what basis, on on basis of what we are calculating a rate of reaction. So I'll tell you here, the rate of any reaction can be calculated on the basis of amount of substance undergoes amount of reactant undergoes reactions to form the product. So amount of reactant getting consumed per unit time, or amount of product formed per unit time, can be called as a rate of reaction. So basically we are calculating change in concentration of reactant per unit time. So change in concentration of reactant per unit time can be called as rate of reaction. So basically rate of reactions can be classified into two parts, instantaneous rate and average rate. In further coming slides we are going to explore about instantaneous rate as well as average rate. Let's explore about the average rate. Okay, so as I told you, that rate of reaction is nothing but what, the change in number of moles per liter. We can say number of moles per liter. Number of moles per liter means what, change in concentration. Moles per liter is what, molarity. So it's we can call it as what, concentration of any reactant or product per unit time is known as a rate of reaction. The rate measured over a long time of interval is called as an average rate. You need to keep in mind that here, that average rate is nothing but what, which is measured a long interval of time. So if it is measured in long interval of time, can be called as an average rate, and the rate measured in infinitesimally small interval of time can be called as a instantaneous rate. So in case of instantaneous rate is measured in for a very infinite small step, or infinite number of steps, or small time interval can be called as an instantaneous rate. For chemical change, reactant and products are involved. See, in any chemical change, if any chemical reaction is happening, chemical reaction is are nothing but a chemical change. केमिकल रिएक्शन जो होता है वो एक टाइप का केमिकल चेंज होता है. तो हर किसी केमिकल चेंज में रिएक्टेंट और प्रोडक्ट रिएक्टेंट रिएक्ट होता है और प्रोडक्ट फॉर्म होता है. ऐसे टाइम पे एज अ केमिकल रिएक्शंस proceed, the concentration of reactant decrease and products are forming. For example, suppose if I'm telling you, if I have taken if A is converting into product B, suppose if A is converting into product B, so initially A was 100% and B is what, 0%. B is 0% and this is what, 100%. So what we can say, if this is 100%, so what we can say, after when the reaction start, A start decreasing and B start forming. So we can say A start decreasing and B start forming. So we can say A is decreasing and B is forming. So we can understand over here the reactant is started decreasing and products are produced. So products are getting formed. So rate of any reaction, average rate, is defined as change in concentration of reactant or product per unit time. So you should keep in mind that you should note it, that is rate of any reaction is nothing but what, change in concentration of reactant or product per unit time. So basically what we conclude, that any change may happen in the reaction, whether product is increasing or reactant is decreasing per unit time, that change can be calculated as the rate of reaction. Okay, there is one more topic about average rate. So as if we'll consider about if A is converting into B, let us understand A is converting into B. So symbol A stand for molar concentration. So you must be aware about, if A is converting into B, if A is converting into B, we can see the concentration, this bracket of A, we are writing this bracket of A. So this bracket indicates the concentration. The bracket indicates what? Concentration. And the symbol delta before the bracket, the delta before the bracket indicate the change in concentration. So this delta stand for change in concentration and this bracket stand for concentration concentration of reactant. So we can say in the if only the bracket A is coming, it means we can say active masses of reactant A, or we can say concentration of A, and delta, if it is delta coming, so we can say change in concentration of A. So what we are getting over here, the rate if rate of any reaction decrease or increase in a concentration of reactant or product may also be expressed in the term of change in their concentration during the time interval. So what we can say, delta T means what, in a common words, if we can say, if you want to calculate the rate of any reactant or product, if you want to calculate the rate of consumption of A, as I told you, A is getting consumed and B is getting formed, or B is formed. So we can say, if we are calculating the rate of consumption of A, then you should write that rate of any reaction is equal to rate of any reaction is equal to rate of consumption of A is equal to, we can say, change in concentration of A per unit change in time. Okay, per unit change in time. So we can say per unit change in time, but you can see here we have used the minus sign over here. Why this minus sign indicate? What this minus sign indicate? This minus sign indicate about the decreasing in the concentration. It expresses the decreasing in the concentration. So if you want to write the average rate of reaction of A, so you can write like this way, the change in concentration delta A by delta T, and that is what negative sign is indicating that decrease in concentration. And here you can say concentration delta is what, nothing but change in concentration of A, and delta T is change in concentration of T. Okay, so average rate of reaction is equal to B ka, for B, if you want to write for B, you can see over here, in case of B you can write delta B, the concentration of B upon delta T. Here we have not used the negative sign. Why? Because B is forming. So if B is forming, so concentration B is increasing, and here the amount of A is decreasing. So we can say that in case of average rate is nothing but what, change in concentration of reactant or product per unit change in time. As we saw over here, that the concentration of A is decreases, so we are using the negative sign, and concentration of B is increases, so we can say we have used the positive sign. So rate of consumption of A and rate of formation of B, if number of moles of A and B are same, they will be same. Means, for example, if we are having A and B, if we are having A and B are two reactant, A and B are two reactant, if we are having A and B are two reactant, so in case of A and B are two reactant, this is also 1 mole, this is also 1 mole. So number of moles of A is equal to number of moles of B if both are same. If both are same, number of moles are same, so we can say they are unimoleculars, and their number of moles are same. They are elementary reactions. So in case of elementary reactions, the rate of consumption is equal to rate of formation. So we can say rate of consumption is equal to rate of formation. So we can write this one, the equation 1 and equation 2 will be equal, so that will be called as an average rate for a reaction. In a case if you're getting this is 1 mole and this is 2 mole, so I can say 1 mole of A is getting consumed to form 2 mole of substance. So there so you need to write the average rate in a different way that we are going to discuss if their number of moles are not same. Okay, so in general what we are getting, the average rate of any reaction is nothing but a change in concentration of one of the reactant or product upon time taken, as I discussed about change in concentration of any reactant of reactant or product per unit change in concentration. So we can conclude that plus or minus change in concentration upon T, where DC, see it's not DC, it's delta C, it's delta C is change in concentration of reactant or product during the delta T. Delta T is nothing but change in time. Okay, so again I'm telling you, see they have written the plus and minus. When it will be plus, when it will be minus, so we can say the rate will be positive at which the concentration of product is increasing. When the concentration of product is increasing, so we can say it is positive, and when it is decreasing, we can say it is negative. So during a reaction, reactants are getting consumed and products are formed, so reactant are always decreasing. So reactant rate of any reactions, a reactant in any reactions, we are putting as a negative sign, and the product we are putting as a positive signs. I hope it is clear now of the rate of average, average rate of any reaction. So to calculate average rate of reaction, simply you can use the same formula, change in concentration of reactant of anything about product or reactant per unit time. You can use that formula, but you have to mention the sign. That is very important. The sign is very important. Positive sign and negative sign. Positive for product and negative for reactant. I hope this topic is clear. Kindly make the note and we'll move for the next slide. Okay, let's move for the next slide. Basically, rate of reaction is not uniform in nature. Rate of reaction is not uniform, it's variable. It's not increasing linearly, like if we can say it is increasing directly proportional. So it's not linear, it's not like that way linear, decreasing linear or increasing linear. It's not uniform, it's variable. It goes on decreasing from the moment to moment due to decrease in the concentration of reactant with progress of reactions with the time as shown below, the rate versus time curve, and thus the rate defined above it actually the average rate of a reaction during the time interval. Let's understand this with the help of one example, a basic example, a day-to-day life example. If I want to discuss, I can tell you. See, so take a glass of water whose temperature was room temperature 25 degree. Put a thermometer in that. Okay, now you start heating that particular glass. Okay, what will happen? Now temperature, you will find it is suddenly increasing. It's increasing. Now initially it absorbs first, then 26, 27, 28, 29, 30, 31, 30. It's like suddenly it is increasing as the time passes. Like you will be able to see within a minute 5 to 6 degrees increase. Then next 1 minute 10 degrees increase. The next minute 5 to 7 degree increase. Then next minute you will, after some time you will find that it reaches to 100, and you are keep on heating, but it remains at 100. It is not changing now. It means it is happening with the same thing. If I'm plotting a graph for that, initially it is increasing and it remains constant. So here it remains constant after some time. And same thing for decreasing, suddenly decrease and remain constant here. So this part, once they are reaching to the this range is called as the equilibrium range, that we are going to discuss a topic that is called as chemical equilibrium. That is a topic of chemical equilibrium. So when I'll just give you the definition of chemical equilibrium. Chemical equilibrium is nothing but a what? It's change in rate of forward reaction, or rate of increment and rate of decrement are same. When speed of increment and speed of decrement are same, we can consider it as a at equilibrium. To understand the equilibrium, if I will tell you, suppose if a hot cup of coffee, if I'm having hot cup of coffee, in that particular coffee, if I am initially it was 75 degrees Celsius, suppose. Now if I'm keeping on table, after some time I'm getting that drastically change. I saw like it becomes 55. After some time I'm getting that it reaches to somewhat 30 degree, 20 means like 40 degree, then it comes to 30 degree. After once it reaches to room temperature, I continuously am measuring with the time, but it is not changing with the time. It reaches to equilibrium. So once it reaches to equilibrium, means what? The rate of heating. It does not mean that it is nothing is happening. It is happening. But what is happening? The happening is what? That rate of forward reaction and rate of backward means we can say rate of heating and rate of cooling are equal. Once it becomes equal, rate of heating and rate of cooling becomes equal. What we can say? We can say the reaction is reached to the equilibrium. That is a different topic that we are going to discuss in the chemical equilibrium topic. But before that we have to understand what is the rate of reactions. And as we can see, there is a graph, and with the help of graph we can see the concentration of A is decreasing and concentration of B is increasing. So in the graph you will be able to identify the concentration of B is increasing and concentration of A is decreasing. Okay, so you will be able to see how the concentration of A is increasing and decreasing. So it is not uniform, that you have to keep in mind, that rate of reaction is not uniform. Okay, to understand this well, here one diagram is given. Like we can see in the first container, when the reaction was started, initially when the reaction was started. So when the reaction was started, we saw the reactant was too much, reactant was full, and product was 0. Here you can say product was 0 and reactant was 50. Reactant was 50 and the product was 0. After some time, after 10 second, what you can see, the reactant reaches here, and product also reaches there. And what we are getting over here, that you can see in the diagram, next diagram, you can see that some of the product are started forming. The pink color one is the reactant A, and the green color one is the product B. You can see they are started forming. Now the process, the reaction will proceed for further, you will be getting the pink color are getting decreases, means we can say concentration of A is getting decreases in every reactions, and finally once you reaches to product, only B formed, B remained, and A get decreases. So what we conclude from this, we can conclude from this, that is what rate of forward reaction, we can conclude that reactants are getting decreases and products are getting consumed. So you have to note it, that as the reaction proceed, during rate of reaction, reactants are getting consumed and products are forming. Okay. Over the same interval of time T1 and T2, the concentration of B changes. B, as I explained you about the previous graph. So what is happening, the average rate we can write, that is what delta B, change in concentration of B by T, is equal to B T2 minus T1 upon T2 minus T1. That is what change from initial to final. Since what we can say, 1 mole of a product and 1 mole of 1 mole of B, rate of decrease in concentration should be equal to rate of the formation of B, we can say formation of B. So here we can write the average rate, that as I told you that if the number of moles are same, their rates will be same, only the direction will be different. So what I can tell you from the graph, that is what, if the number of moles of A and B are same, so rate of increment and rate of decrement will be same. Means what we can say, within 1 minute 10 moles are decreasing, so within 1 minute 10 moles are forming. So we can say rate of increment and decrements are same, only the change is what, the formation and the consumption. So we can say decrease or increase is only the change, and the speed of the formations will be same. So that can be taken as an average rate. See, units of the rate of reaction. Every rate of reactions are having their unit, but obviously they'll have the unit. What is the unit? How we'll be able to do? So we know the formula, change in concentration upon change in time. So time is in second and concentration is what, mole per liter. So we can say mole per liter per second. So you can calculate the mole per liter per second. So that can be calculated. So per second you can calculate, or you can calculate per second, or you can calculate per minute, per hour, per day, or per year. It depends upon the time, how much. If it is going for per year, we can call it as it's very slow reactions. If it is going with a per day or per hour, it is moderate reaction. If it's taking seconds or minutes, we can say fast reaction. So basically speed of reaction is nothing but what, dealing with the time of reaction. So here one ideology you should make in your mind, that is rate of reaction. If I'm talking, so I'm talking about the speed of reaction. See, expression of the rate. If we'll understand about the expression of the rate, so we can get over here, like suppose, as I told you, like if their number of moles are not same, if the number of moles are not same, if you'll just see in this reaction, so what you're getting, that is what, 2N2O5 undergoes dissociation to form 4NO2 plus O2. So you're getting number of moles are not same. So how you'll write the average rate for them? You need to first write the rate for every reaction. You need to write the rate for every reaction. So what you're getting over here, just a second. So you can see over here in this equation, you will be able to get minus delta N2O5 upon delta T. Now question arises over here, why I am writing minus sign over here? Because it is reactant. I can write delta NO2 upon delta T. Why I am writing plus sign over here? Because it is what, the product. And same we can write for O2, which is product. So if the number of moles are not same, what we need to do? We need to balance the coefficients. And so what we need to do? These individual rates may be equal to one another by dividing them by a respective stoichiometric coefficient in the chemical equation for the reaction, and thus rate of reaction is equal to minus 1/2. See, I'll give you the very easy clue. आप सभी को एकदम easy clue दूंगा कि यहाँ पे जो नंबर्स लिखे होते हैं, यहाँ पे जो नंबर्स लिखे होते हैं, उस नंबर को आपको सिर्फ क्या करना है, उस नंबर को आपको सिर्फ उसको डिवाइड कर देना है नंबर ऑफ मोल्स को. व्हाई वी आर डूइंग? बिकॉज सी, वी नीड टू मेक इट इक्वल. वी सपोज वी कैन से 2 moles of N2O5 is producing 1 mole of oxygen. So what I can say, 2 moles are producing 1 mole of oxygen. So to make them balance, what we need to do, half mole of, means just what will happen if the 2 time of any reactant are present, 2 time of any reactant is present, so we are just the rate becomes half of it. So we are taking it as what, just half of it, and you will be able to get it. So whatever number is there, you just make it divide by that number, you will be given 1 by divided by that number, you will be getting the answer for the that particular reactions. I hope this equation is clear. Like, can you try for this reaction? N2 plus 3H2 gives us 2 moles of ammonia. Can you try for this reaction? N2 plus H2 gives us 2 moles of ammonia. Okay, so for 2 moles of ammonia, so what we will write, this is what, delta N2 upon delta T. This will be in minus and this 3s2. So what I'll write in the average rate, minus 1 by 3 delta s2 upon delta t. Here I'll do the plus 1 by 2. So whatever number is given over here, now whatever the stoichiometric coefficient over here, if you'll divide by, simply divide by that, you will be able to get it. It's a very easy trick. Either you can just see their number of moles on the basis of number of moles and stoichiometric coefficient. If you'll balance the stoichiometric coefficient, you are going to get the average rate. So that is one more trick for to do this. Okay, one more topic comes, that is what instantaneous rate. Now we discuss in detail about the average rate. Now let's go ahead with instantaneous rate. What is instantaneous rate? In chemical kinetics, the rate of rate at any particular instant, that is instantaneous rate, rather than the average rate over a time interval. So it means what happens, no, like we are finding the rate at every instant means every after 1 second, after 1 minute. So continuously we are finding at every instant what is the rate. So as we saw, the rate is not the periodic, we can rate is not the continuous in nature. It's not in continuous, it's not in periodic in nature. So we can say it is gradual. So we'll be able to find the different rates at different time interval. So it is defined as what rate of change of concentration of any one of the reactant or product over very small time interval. If we take infinitesimally small interval of time dt, it may be assumed that the rate is uniform through the interval. Then if dx, see, only the things what we are going to change in this, that is what we used to use the delta for change. Okay, for big change we used to use the delta. Now we have to use the d. We have to use the d for the change, for small change. For every small change we are going to use the d. So if you'll write the change of dx by dt, it means that it is change, the very small change in the reactant per unit, very small change in the time. So very small, if there is a very small change, you have to use the d, and if there is a big change, you have to use the delta. And same जैसे आपने एवरेज रेट में किया कि उसके नंबर ऑफ मोल्स, जो भी नंबर ऑफ मोल्स थे, उस नंबर ऑफ मोल्स को आप डिवाइड कर देते थे उस नंबर से, तो आपको आंसर आ जाता था, एवरेज रेट आ जाता था। उसी प्रकार इंस्टेंटेनियस रेट में भी आपको वही करना है, सब कुछ वही सेम टू सेम करना है। सिर्फ क्या करना है, एक स्मॉल इंटरवल टाइम पे होगा, इसमें हर छोटे छोटे स्मॉल स्टेप्स मिलेंगे, इन्फिनिट नंबर ऑफ स्टेप्स मिलेंगे। तो इसमें भी रेट वही होगा, सिर्फ रेट की क्वांटिटी छोटी होगी, रेट की वैल्यू क्या होगी, छोटी होगी। क्यों? क्योंकि हम छोटे टाइम चेंज पे कर रहे हैं। जैसे अगर देखिए, अगर मैंने बताया, एक एग्जांपल दिया था आपने भी थोड़ी देर पहले कि अगर एक हॉट कप ऑफ कॉफ़ी है जिसका टेम्परेचर 70 डिग्री है, आप हर 10-10 मिनट में चेक करेंगे तो बड़ा चेंज आएगा आपको। पहले 70 था, फिर सडनली आपको 55 मिल जाएगा, फिर 45 मिल जाएगा। यू विल बी गेटिंग द बिग चेंज आफ्टर 10 मिनट, आफ्टर लॉन्ग इंटरवल इफ यू आर डूइंग। बट इफ यू आर डूइंग फॉर एवरी शॉर्ट इंटरवल, मीन्स व्हाट, नाउ 70 है, 70 डिग्री था, और अगले ही 30 सेकेंड्स में आपने अगर चेक कर दिया तो 70 से डायरेक्टली 55 तो आने वाला नहीं है। तो आपको ये चीज़ समझना होगा कि स्मॉल इंटरवल टाइम में अगर आप कर रहे हो तो रेट के डिफरेंसेस भी क्या होंगे, छोटे होंगे। तो रेट के डिफरेंसेस छोटे होंगे, तो इसीलिए डेल्टा यूज फॉर बिग चेंज, डी वी आर यूजिंग फॉर स्मॉल चेंज। तो यहाँ पर आपको एक क्लियर आइडिया आ जाएगा कि इंस्टेंटेनियस रेट इज नथिंग बट एवरेज रेट, ओनली द थिंग इज व्हाट इट इज कैलकुलेटेड एट एवरी इंस्टेंट ऑफ टाइम, एवरी स्मॉलर instant of time we are calculating, that can be called as a instantaneous rate, and we are using a term can be called as a d. We are using d as a term, not delta, for denoting the change. So that is what instantaneous rate. If we'll discuss in detail, we can see in a differential calculus that when delta t becomes very small, approaches to 0, the ratios will becomes what, delta dA upon dt. Why dA? Because very small change in concentration will be there and very small time will be there. So you can write what? Rate of instantaneous reaction will be equal to limit delta t tends to 0. Delta t tends to 0, it means change in time is very small time interval. After very small time interval we are checking, that's why we can write minus dA by dt. Minus sign again here indicate the what it indicate? It indicates the consumption of reactant. Okay, reactants are getting consumed. On other hand, if the rate of reaction is expressed in terms of concentration of reactant or product, which goes on increasing, then the rate of reaction of the particular instant can be written as positive or dx by dt. Very simple. If you are calculating for consumption of reactant, you will be getting negative. If you are getting formation of product, it will be positive. In general, for a reaction, N1 A plus N2B gives us M1C plus M2D. अगेन इट इज कमिंग एंड द सेम आई टोल्ड यू, जैसा मैंने बताया था कि एवरेज रेट में हम क्या करते थे, जो भी नंबर ऑफ मोल्स रहते थे उस नंबर ऑफ मोल्स को हम डिवाइड कर देते थे. अगर वो रिएक्टेंट होता था तो हम माइनस साइन लगाते थे, अगर वो प्रोडक्ट होता था तो हम पॉजिटिव साइन लगाते थे. तो यहाँ पे अगर आप ध्यान देंगे कि N1A प्लस N2B मीन्स N1 और N2 क्या है, यहाँ पे नंबर ऑफ मोल्स ऑफ A है और N2 क्या है, नंबर ऑफ मोल्स ऑफ B है. M1 क्या है, नंबर ऑफ मोल्स ऑफ C है एंड मोल्स ऑफ D है M2. द इंस्टेंटेनियस रेट अगर आपको लिखना है तो आप क्या लिखोगे, वैसे ही लिखना है. रेट इज इक्वल टू आप क्या लिखेंगे, 1/N1 ऑफ dA by dt. दैट विल बी नेगेटिव एंड हियर इट शुड बी नेगेटिव, राइट? हियर इट विल बी नेगेटिव. ओके, and you can write minus 1/N2 dB by dt. Same way, minus 1/M1 by C, sorry, positive 1/M1 dC by dt and 1/M2 dd by dt. So it's very simple. You need to just follow the same rule of average rate. Only the thing is what, you need to use the delta sign instead of delta sign you need to use the d. I hope this till here it is clear. Okay, so some experimental determination of instantaneous rate. How to determine the experimental way? So we'll be able to determine the average rate, instantaneous rate for any reaction by drawing a tangent on it. By drawing the tangent on the gradual decrement on increment. So what we can say, the two graph you can see over there. Rate of reaction at any time t may be determined by plotting the concentration of reactant or product versus time and drawing the tangent at the point P of the curve corresponding to the time t. Which rate is to be determined, and the slope of the tangent gives the rate of reaction at the required time. So what you can see, if you'll plot a graph against the concentration of reactant upon time, so you'll be able to get a reactant and versus time on x-axis, a reactant on y-axis, changing concentration of reactant on y-axis. You are getting the reactants are getting decreased and products are forming. So you will be able to calculate the slope of the tangent. By plotting a tangent you will be able to get the slope. So if you'll find the tangent, you'll be getting the slope. The slope will be negative slope and you are getting minus dr by dt. That is what the rate of the reactions. Same way you will be able to find for the another one for given point for the increase, for increasing the rate of this thing. So rate at the time t is equal to slope of tangent. Slope of tangent. I hope you are getting the slope of tangent can be calculated by the, how you will calculate the slope, y2 minus y1 upon x2 minus x1. That is the formula for calculating the slope. Okay, one more terms comes, that is what rate constant. Rate constant. Before studying the rate constant, we should know we should understand a topic called rate law. Rate law is nothing but working on the basis of law of mass action. As we said, that rate of any reaction is equal to or we can say very simple, we can say rate is directly proportional to product of concentration of reactant raised to their stoichiometric coefficient. So we can say suppose if I'm having a rate is directly proportional to active masses of reactant. Reactant is A for this reaction. Reactant raised to their stoichiometric coefficient. If any coefficient is there, so that raised to their coefficient. Here no coefficient, so we will not write any coefficient. So is directly proportional to concentration of reactant raised to their stoichiometric coefficient. If you remove this proportional sign, you will be getting the rate is equal to K into A raised to whatever the coefficient is there. If no coefficient, it's 1. If any coefficient is there, then you need to put the coefficient on that. So you are getting this equation. This equation is called as a rate equation. Rate equation. Okay, so again I'm repeating, please make a note. Here should be before than this, we should understand the rate law. What is rate law? Rate law defined as rate of any reaction is directly proportional to product of concentration of only reactant. In this case, we are not bothered about the product, we are only bothered about the reactant. So rate of any reaction is directly proportional to product of concentration of reactant raised to their stoichiometric coefficient. And if you'll remove this proportionality sign, you are getting one constant term. That constant term itself is called as a rate constant. That term is called as a rate constant. So I hope I'm making clear. The rate constant is nothing but it's what? It's a proportionality constant of rate law or rate equation. It's a proportionality constant of what? Rate law or rate equation. So rate constant, I hope it is clear. Okay, let us understand with the help of this example how to calculate the rate constant. So if you are having a reactant, you can see over here, if I'm having a reaction, AA plus BB gives us product. As I told you, in case of rate law, we are not bothered about the product, we are only bothered about the reactant. So in case of this, we are having AA plus BB gives us product. So you can see the rate is equal to dx by dt is directly proportional to concentration of A raised to A and B raised to B. So you can get over here concentration of A raised to A and B raised to B, and if I'll remove this proportionality sign over there, so I'll be getting what? K is equal to rate is equal to K, A raised to A and B raised to B. If I am what is this K? I told you K is nothing but a rate constant. If concentration of A and B are 1 mole per liter, means what we can say, if the change is happening, or if the concentration of A is 1 if 1 mole per liter, so 1 into 1 will be 1, so we can say rate constant is equal to rate if the concentration is 1. So we can say a rate of any reaction at unit concentration of reactant is called as a rate constant. So the definition comes, rate of any reaction at unit concentration can be called as a rate of reaction. So what is rate of reaction? Rate of reaction is rate of reaction at unit concentration of reactant is called as a rate constant. Now one more terms is there. Which value will alter the rate constant, means when the rate constant will increase or decrease, or which value will alter the rate constant. So very simple सा इसमें सवाल है कि ऐसे कौन से टर्म्स होंगे जो किसी रेट कांस्टेंट किसी रिएक्शन के रेट कांस्टेंट यानी कि के वैल्यू को अल्टर करेंगे, के वैल्यू को चेंज करेंगे, डिस्टर्ब करेंगे. कौन से ऐसे टर्म्स हैं? तो ऐसे 3 टर्म होते हैं, नेचर ऑफ रिएक्टेंट, टेम्परेचर एंड कैटलिस्ट. सी आप लोगों ने सुना होगा नेचर ऑफ रिएक्टेंट. अगर देखिए क्या होता है, 2 रिएक्टेंट अगर आपस में रिएक्ट करते हैं, ओके अगर उनमें फिलिसिटी नहीं है मतलब रिएक्ट नहीं करना चाहते हैं, अगर वो रिएक्ट नहीं करना चाहते तो ऑटोमेटिकली रेट ऑफ रिएक्शन स्लो हो जाएगा. तो ऐसे टाइम पे ऑटोमेटिकली क्या हो जाएगा कि के वैल्यू कम हो जाएगा. सो यहाँ पे मैं ये कहना चाहता हूँ कि रेट ऑफ रिएक्शन मतलब कम हो जाएगा, के वैल्यू कम हो जाएगा. कब कम हो जाएगा? जब उनकी फिलिसिटी कम रहेगी. तो नेचर ऑफ रिएक्टेंट एक बहुत इंपॉर्टेंट रोल अदा करता है इसमें, कि बहुत इंपॉर्टेंट रोल प्ले करता है कि नेचर ऑफ रिएक्टेंट अगर दो सब्सटेंस हैं ए एंड बी, आपस में वो रिएक्ट ही नहीं करना चाहते, उनकी रिएक्टिविटी बहुत कम है, या फिर समझ लीजिए उनकी इलेक्ट्रोनिगेटिविटी कम है, इलेक्ट्रोपॉजिटिविटी कम है, ये सारे कंटेंट कम है, अगर वो उनके पास बहुत हाई आयोनाइजेशन एनर्जी लगता है, तो ऐसे केसेस में अगर ऐसे केसेस में उनकी रिएक्टिविटी कम हो जाएगी, रेट ऑफ रिएक्शन कम हो जाएगा, के वैल्यू क्या हो जाएगा, कम हो जाएगा। तो यहाँ पे मैं ये बता रहा हूँ रेट कांस्टेंट अल्टर हो जाएगा नेचर ऑफ रिएक्टेंट की वजह से। आप सबको पता है कि टेम्परेचर जब हम बढ़ाते हैं किसी भी रिएक्शन का, हम जब टेम्परेचर बढ़ाते हैं, तो जब टेम्परेचर बढ़ाते हैं तो क्या होता है, उनके मॉलिक्यूल्स पहले एनर्जी को एब्जॉर्ब करते हैं। एनर्जी को जैसे ही वो एब्जॉर्ब करते हैं, व्हेन एवर दे आर एब्जॉर्बिंग द एनर्जी, दे आर गेनिंग एनर्जी एंड देयर वाइब्रेशन विद इन द मॉलिक्यूल्स आर इंक्रीजिंग, एंड वंस द वाइब्रेशन ऑफ द मॉलिक्यूल्स आर इंक्रीजिंग, देयर काइनेटिक एनर्जी इंक्रीजेस, एंड वंस द काइनेटिक एनर्जी इंक्रीजेस, दे वांट टू गो फार अपार्ट, they want to get dissociate, and in this case can we say that कि पहले जो रिएक्शन होता था उसमें टेम्परेचर ने और अपना इनपुट दे दिया, टेम्परेचर ने और एनर्जी दे के, टेम्परेचर एक फॉर्म में एनर्जी दे के उसको क्या कर दिया, उसके रेट को और बढ़ा दिया। तो हम क्या बोलेंगे कि जैसे जैसे टेम्परेचर बढ़ाओगे रिएक्शन की स्पीड बढ़ जाएगी, रिएक्शन की स्पीड बढ़ जाएगी तो के वैल्यू क्या है बेटा, यहाँ पे देखो इट्स डायरेक्ट वेरिएबल, के इज व्हाट, डायरेक्ट वेरिएबल विद द रेट। सो रेट के साथ डायरेक्ट वेरिएबल है, तो रेट जब बढ़ेगा तो के भी क्या हो जाएगा, बढ़ जाएगा। आगे देखते हैं कैटलिस्ट। आप सबको पता है कि कैटलिस्ट अगर किसी बच्चे से पूछा जाए, जब हमसे 10th स्टैंडर्ड में पूछा जाता था या 11th स्टैंडर्ड में पूछा जाता था, तो हम कैसे आंसर देते थे, कैटलिस्ट इज अ सब्सटेंस विच इंक्रीज द रेट ऑफ रिएक्शन। एक ही लाइन याद रहती थी, कैटलिस्ट इज अ सब्सटेंस विच इंक्रीज द रेट ऑफ रिएक्शन। तो यहाँ पे भी वही लाइन आपको याद करनी है कि कैटलिस्ट इज अ सब्सटेंस विच इंक्रीज द रेट ऑफ रिएक्शन। तो अगर जाहिर सी बात है जब रेट ऑफ रिएक्शन को इंक्रीज कर देगा तो ऑटोमेटिकली क्या हो जाएगा, के वैल्यू रेट कांस्टेंट अल्टर हो जाएगा। तो यहाँ पर आपको तीन मेन चीज़ आपको याद रखनी है कि कौन कौन सी चीज़ें ऐसी हैं जो रेट कांस्टेंट को अल्टर करती हैं। कृपया इसका नोट्स बना लें और फिर हम अगले स्लाइड पर चलते हैं। Next topic is what, unit of rate constant. See, this rate constant is also having the unit, but obviously, and it depend upon the concentration term itself. Like, see, if you are getting 1 moles, so your concentration terms will be what, 1 upon the concentration term will be raised to that stoichiometric coefficient. So यहाँ पे हमने देखा कि कोएफिशिएंट टर्म्स वो उस रिएक्टेंट का रेस टू टर्म हो जाता है, रेस टू टर्म हो जाएगा। तो अगर मोल पर डेसीमीटर क्यूब है, अगर रेस टू 2 हो गया तो मोल स्क्वायर डेसीमीटर रेस टू 6 हो गया। तो यहाँ पे बेसिकली मैं ये कहना चाहता हूँ कि जैसे जैसे रेस टू नंबर्स बढ़ते हैं, नंबर ऑफ मोल्स बढ़ते हैं, वैसे वैसे क्या हो जाता है, रेट कांस्टेंट की यूनिट्स भी चेंज हो जाती है। लेकिन फिर भी यहाँ पे एक जनरल रूल दिया है कि विद द हेल्प ऑफ दैट रूल यू विल बी एबल टू फाइंड आउट द सो यूनिट ऑफ रेट कांस्टेंट इज इक्वल टू 1 अपॉन यूनिट ऑफ कॉन्सेंट्रेशन n-1। सी n-1 you can get n-1 time per unit time is equal to, you can write that liter per mole per this thing, and where n is number of n is order of reaction, where n is order of reaction, where n can be taken as order of reaction. So this formula I will suggest you just please note it down, so it will help you out for calculating order of any it will help, yeah, even to calculate the order of reaction, as well as it will help you out to finding out the unit of rate constant. So I think this is the cream formula for you. Just note it down, and basically if you're not remembering this big part, just remember this part, so you'll be able to understand liter per mole n-1 s-1, where liter per mole, liter is, per mole we are getting from concentration, s we are getting from time, n is what, order of reaction. Okay, so I think this was one top topic, and the one more thing comes, that is what difference between the rate of reaction and the rate constant. So you may be aware about this thing. It's a totally different topic. Rate of reaction is different topic, and reaction rate constant is different topic. Rate of reaction is what, it is a speed which the reactant and products are reactants are converting into product, and this is what the proportionality constant, and it is measured in as a rate of decrease the concentration of reactant and the rate increase the concentration of product with time. So we see that rate increases with concentration of product with time, and with decreases with concentration of reactant. It is equal to the rate of reaction and concentration to the each term and it is defined as the rate of reaction is depend upon the initial concentration of reactant, and here the rate constant is not depend upon the initial concentration of reactant. Here we can say rate of reaction is 0 when the time t is equal to 0, when time t was 0. So what we can say, rate of reaction is 0. How we can say rate of reaction is 0? Because reaction has not started yet. If the reaction has not started yet, no reactant has consumed and no products are formed, so we can conclude over here that is what rate of reaction and rate constant. So this was a big topic of it's a small one topic of chemical kinetics, and which we were dealing with it. Next few more topics are there, and for those topics the upcoming videos will be there based on that. And one more thing is what, see, मैंने ऐसा प्लान किया है कि एक साथ पूरा चैप्टर पढ़ने के बाद अगर हम न्यूमेरिकल करते हैं तो इट विल बी वेरी डिफिकल्ट टू अंडरस्टैंड दैट विच फार्मूला शुड अप्लाई वेयर एंड विच टाइप ऑफ क्वेश्चन विल बी आस्क्ड ऑन दैट. तो हमने सिर्फ आज एक ही टॉपिक को एक्सप्लोर किया है, बहुत डिटेल में एक्सप्लोर किया है. कौन सा टॉपिक है वो? रेट ऑफ रिएक्शन. सो रेट ऑफ रिएक्शन एंड रेट कांस्टेंट को हमने एक्सप्लोर किया है. सो अगली वीडियो में जब भी मैं आऊँगा, अगले वीडियो में मैं लेकर आऊँगा आप सभी के लिए रेट ऑफ रिएक्शन के ऊपर सॉल्व प्रॉब्लम, और बहुत सारे क्वेश्चंस मैं आप सबके साथ में सॉल्व करूंगा, और उसमें मैं बताऊंगा कि कैसे किस टाइप के क्वेश्चंस आपके एग्जामिनेशंस में आते हैं और उसे किस तरह से टैकल किया जाता है. इवन आई विल टेल यू सम ट्रिक्स टू सॉल्व टू देम. सो आई थिंक टिल देन यू जस्ट रिवाइज दिस टॉपिक and do it well. Thank you so much for being such a wonderful audience, and as I told you, the for salt example based on the rate of reaction, please watch the upcoming video. In upcoming videos there will be the solution and solved example for this all, and how to apply the rate of reaction. And अगर आपको ये सब वीडियो अच्छा लग रहा हो, अगर आपके लिए ये हेल्पफुल हो, आपको समझ में आ रहा हो, तो अपने दोस्तों तक ज़रूर पहुँचाएँ. Thank you so much for being wonderful audience. Thank you so much.